Hello and welcome back to the channel. In today's episode we're going to be looking at the core content 1.8, which specialises in the categorisation of metals, specifically ferrous and non-ferrous metals. That's what we're going to be learning about in today's session. Let's get started. Okay, ladies and gents, so before us we have a series of metals that have been laid out for us in front of our timeline sort of thing. Now this timeline over here, this is going to be of course our melting points, how hot these metals need to be before they melt. Now let's start off on the, well actually I'm going to start in the middle here. I'm going to start here at this section because here we've got a very important metal, iron. Now iron's really important here, especially when we're talking about this here, ferrous and non-ferrous. Well, what are the difference between those two? Essentially we have two families of metals. We have the ferrous metals and non-ferrous metals. We might be thinking, okay sir, but what does it mean? What does it mean if it's ferrous? Well, before I get into that, interestingly enough, in the periodic table, for all you scientists out there, you'll notice that our iron here is referred to as Fe, which is the shortened down version of ferrous. Now, what ferrous means is, ironically, is it contains iron. Specifically in iron's case, 99.95% of it is actually made up of iron. Now, because iron is ferrous, it does one of two things. Number one, it will rust if left out in the rain, or if it gets wet, or if it stays out in the elements. And number two is that it is magnetic. So if you put iron towards another ferrous metal, they will connect together and become magnetic. Now, iron is really important because it's ferrous, because it will rust, because it makes up quite a lot of other metals. Now, as you can see from this metal over here to the side of it, which is very, very rusty, we have this very tough and strong metal called mild steel. Now, mild steel is known for being quite a heavy metal, yet it is still malleable. I can still move it and bend it, and I can cut with it and shape it. Hence why we used to use steel to make swords, because we can melt them down and we can turn them and forge them into weapons, I suppose. But now we don't really forge steel weapons so much anymore. We use it for construction because of its strength properties. Now, in between these we have this very special metal here. Now this is called stainless steel. Now stainless steel is I'm going to put a star next to it because it is the only exception to the ferrous metals. It doesn't rust, mainly because of this special coating that it's got around the outside that makes it nice and shiny. Now we use that a lot, of course, on things like cutlery, like knives and forks and spoons, etc. I mean, I couldn't think of anything worse than eating a bowl of porridge with a rusty spoon now. So anyway, that divides our ferrous metals there, and then to the other side, which is down this way, we have our non-ferrous metals. So these are our non-ferrous metals here, and of course we'll start left to right, I suppose. We have our aluminium, which is made up of 99.999% of aluminium, and you'll notice here that this is the lightest of the metals. And what's brilliant about aluminium is the fact that it is lightweight, because it's strong. It's strong and it's lightweight, which makes it a perfect metal for building things that need to go quickly, need to be light or picked up, lightweight, but also need to have some strength to them. Moving down the line, we have brass, which is what we use to make those musical instruments out of, which is why we call them brass instruments. Now, I would say that brass is quite attractive in terms of its colour. It's got like a goldy looking appearance to it. So it's quite goldy in its appearance. I'll put gold like because it's not actually gold. and it makes it very attractive. So in terms of metals which look good, brass probably takes top place. Coming in second place would probably be aluminium, quite silvery. And then probably, in my opinion, in third place would come copper. Again, it's not a nice reddy colour or reddish tone to it. Reddish tone, which makes it quite attractive. And also, it makes it a brilliant conductor of electricity. So, conducts electricity. You might be thinking, well, what do you mean by conducts electricity? What does conduct mean? So, a long time ago, in your great-grandfather's day, there used to be these buses, and at the back of the bus they'd have an opening, and you'd have a chap sat there with a ticket machine, and he would be the bus conductor. Now what his job was to enable people to come onto the bus, so he allowed them to come on. Equally, if he was a good conductor, he'd let lots and lots of people onto the bus and make lots of money for the bus company. It's the same thing with copper being a good conductor of electricity. It lets lots of electricity flow through it, which is why it becomes such a good conductor. Now, let's talk a little bit about melting points. So here, where we have aluminium, we have a rather low melting point of 660 degrees Celsius. That's the point at which the metal will turn from a solid, of course, into a liquid. Now, brass has the next lowest melting point, and that is anywhere between 900 to 940 degrees Celsius. So we're getting quite hot now, aren't we, really? But still, not quite as hot as copper, which is our hottest non-ferrous metal on our timeline, or on our melting point line rather, at 1100 degrees Celsius. So copper takes a lot higher temperature to melt, almost twice as hot as aluminium does to melt. Remember, aluminium is lightweight and strong, but you would also consider that metal to be quite soft. Now, the harder the metals they get, the higher that temperature needs to be. Now, if we move over to iron, now iron, of course, this one has a melting point of 1200 degrees. Now, the difference here is that iron is quite a brittle metal. So if it gets hit hard with something, it's likely to shatter and break. But it's very hard, which is one of the decent properties that iron has. Moving up the line, we have our next two, or our last two hottest lines, which are this one over here, which is 1400, and well, because it's all metal, they're all the same, so it's 1400 degrees over here as well. So both mild steel and stainless steel have the same melting point. Despite that coating on the outside over here, it still has a melting point of 1400 degrees Celsius. Now, just to finish off, at this point, I'd like to say a roundup of what we've learned. So, we've learned about ferrous and non-ferrous metals in today's session. We'll be able to identify now that there are two major properties of a ferrous metal. One of them is that it will rust if you're left out in the wet. The second is that it becomes magnetic. We've learned, of course, by the flip side of that a non-ferrous metal won't rust, or it will resist rusting, and that they are non-magnetic, so they don't connect to each other. We've learned that aluminium is by far our softest and lightest metal, and it has the lowest melting point at 660 degrees Celsius. We've learnt on the other side of the spectrum that mild steel is one of our harder metals, and it has a higher melting point, well over double aluminium at 1400 degrees Celsius. We've recognised that the non-ferrous metals such as copper and possibly even brass have high conductivity for electricity. And we've learnt that stainless steel is the only exception to the ferrous metal tree that allows it to not rust or resist that corrosion. Now, to finish off, we have a couple of properties to go through, and they're fairly straightforward in the sense that aluminium is this greyish white in its appearance. It's quite ductile, which means we can, and malleable, which means we can shape it. The brass, again, is corrosion resistant. Resists corrosion. I couldn't make my mind up then if I was going to say doesn't rust or resists corrosion there. Copper, of course, we talked about that being an electric conductor, or one of the better conductors of electricity. Iron is, well, it's hard. It's very hard, very brittle. But one of its nice things about it is that it is magnetic, so we can connect things to it. So again, that is one of the big properties of iron. Stainless steel, on the other hand, one of the bigger properties for stainless steel, of course, is it's corrosion resistant. But interestingly, actually, just having a look at my notes down here, interestingly, one of the nice things about this is that it's sometimes magnetic. So we can put here that sometimes magnetic. And I suppose, quite interestingly, that might well be because those ferrous properties and the fact that it is a ferrous metal. However, that coating possibly dulls some of that magnetic property from it. Perhaps it's something to have a go at home. See if we get a magnet. If you've got one at home, maybe you could try lifting up some knives and forks and seeing if they pick up. Some of them might do, some of them might not. Be interesting to see which ones do and which ones don't. And lastly, our property of mild steel, of course. Looking at my notes, again, very malleable. We can manipulate it, we can shape it, we can cut it. It has a huge tensile strength, so it's a very strong metal. And there are a few properties of those ferrous and non-ferrous metals. So that's today's session, looking at this categorisation of ferrous and non-ferrous. Hopefully you use this as part of your revision, so that you guys who are doing the core content, possibly doing a paper and boards exam, or possibly a timbers exam, who need to know a little bit about those metals, can have this as a way to maybe mind map some ideas and maybe test parts of that knowledge on those two different types of metals. So, as always, thanks for watching. If you don't want to miss another video, don't forget to subscribe. I've been Mr. Davey. Stay safe. Bye now.